Alright, for this problem we want to make sure to label the diagram. Here we have 24, then we have 16, then we have 20, 36 is 30. Alright, so we want to write a similarity statement here. So I have to find what corresponds to A, B, and C. Okay, so I'm going to go with the shortest side from the small triangle over the shortest side for the big triangle. So that reduces to 2/3. Okay, so AC corresponds to BC. Okay, so I'm going to have B here, and then C. Alright, and then I have the medium side, 20, corresponds to the medium side over here, 30, so that reduces to 2/3. Alright, and so that's BD, so AB corresponds to BD. Alright, so we're moving in the right order now. Alright, so AB corresponds to BD, BC corresponds to DC, AC corresponds to BC. Alright. Okay, now we could prove these triangles are similar by what shortcut? Well, I'm working with the side lengths, so I need to work with the last pair of side lengths. I have 24 corresponds to 36. That's 2/3 as well. So these triangles are similar by SSS. Alright, on to the next. They tell you triangle MNO is similar to RST. Find RT. Alright, if they're similar, then M is congruent to R, N is congruent to S, and O is congruent to T. Alright, now let's see, find RT. Here's RT. Okay, so RT corresponds to what? MO. MO is 8. Then I have this side here, which is 4.5. That's RS. RS corresponds to MN. MN is 3. Alright, so now I'm going to cross multiply. And I get 3RT is equal to 36. I divide by 3, and RT is equal to 12. Done. Alright, Jamie knows the lengths of two sides of a triangle are 8 and 12. Determine the possible values for the length of the third side of Jamie's triangle. Alright, so the third side is x. So here are all the relationships that exist. Any two sides should be greater than the third side. Alright, so here I have 20 is greater than x is less than 20. Subtract 8, x is greater than 4. Here I subtract 12, x is greater than -4. Now we're not going to use that information. I know that the value for x is between 4 and 20. So 4 and 20, I put the x in the middle, and I'm going to create a compound inequality. Compound meaning that I'm combining two inequalities in a 1, and they both point to the left. They'll always point to the left for a compound inequality. Alright, so x has to be greater than 4 or less than 20. Done. The lengths of the two sides of a triangle are 2 and 3. The third side cannot be, alright, the third side, x. It cannot be what? Alright, so I'm going to set up the three conditions here, 3 situations. I have 3 plus 2 has to be greater than x plus 2 has to be greater than 3, or x plus 3 has to be greater than 2. Alrighty. So not doing that anymore, done with that. Alright, so x has to be between 1 and 5. Alright, which of these values is not between 1 and 5? Be this one. Alright, so it cannot be, the third side cannot be 1 or A. Okay? Alright, in the quadrilateral, measurement angle A equals 2x minus 40. This is 2x minus 40. Alright, B is 3x minus 48. C is 2x minus 30. And D is x plus 118. Alright, what is the value of x? Alright, since this is a quadrilateral, what do all the angles add up to? They all add up to 360. So let's add all of these expressions up. Set equal to 360. All right, you got x, 2x, 2x, 3x. So you have 8x. You got 118 minus 30 minus 40 minus 48. All right, so minus 70 minus 118. Wait, these all cancel out, don't they? Yes, they do. Okay. All right, 118 minus 118. So that equals 360. Divide by 8. And x is equal to 45. Done. Alright, they say D is 74 degrees here. C is 127 degrees. A is 91 degrees. What is the measure of B? Okay, these are vertical angles here. So that's 91 degrees. This is a linear pair here. So 127, subtract that from 180, and you get 53 degrees. Alright, now what do all the angles of a quadrilateral add up to? They add up to 360. Alright, so 91 plus 53 plus 74 is 218. Subtract 218. And B is equal to 142. Done. All right, in the diagram, the marked lines are parallel. All right, arrowheads indicate that the lines are parallel. Measurement angle 1 is 60 degrees, 2 is 53. Find the measures of 3, 4, and 5. Okay, that shouldn't be too difficult. Alright, so here I have a triangle, and so I'm going to subtract 60 plus 53 from 180 to get angle 3. So what's angle 3? Angle 3 will be equal to 67 degrees. Okay. And now I want to figure out 4. How am I going to do that? Well, notice that these are alternate interior angles. So that's 60. And then you could also notice that these here are corresponding angles. So that's 53. All right, and you have all of them. There are different ways to go about getting those angles, but that was just one way. All right, on to the next problem. All right, they tell us that these lines are parallel, so I'll put arrowheads on the line to indicate that they're parallel. Okay, and it says IUO is 50, and UPE is 120. I have to figure out the measure of IUP. So this angle measure here. Well, these two angles here are consecutive interior angles, so that's more, they have to add up to 180. So this is 60. All right, and all three angles combined here form a straight angle. So 50 plus measurement of angle IUP plus 60 is equal to 180. So I have 110 plus measurement of angle IUP is equal to 180. Subtract 110. Measurement of angle IUP is equal to 70 degrees. Done. The diagram shown was the measure of ACE. ACE right here. Okay, so this is an isosceles triangle. These angles are equal. So I'll call these x. So I have x plus 55 equals 180. 2x plus 55 equals 180. Subtract 55. 2x is equal to 125. So I divide by 2, and x is equal to 62.5. All right, so that's 62.5. That's a 2. 62.5. Okay, then we have this isosceles triangle, 100 degrees here. These angles are congruent. I'll call both of these y. So y plus 100 is equal to 180. 2y plus 100 equals 180. Subtract 100. 2y is equal to 80. Divide by 2. Y is equal to 40. Okay, so that's 40. That's 40. All right, now I'm going to add up all these angles together because they form a straight angle. So 62.5 plus measurement of angle ACE plus 40 is equal to 180. So now I have 102.5 plus measurement of angle ACE is equal to 180. Subtract 102.5. Measurement of angle ACE is equal to 77.5 degrees. Done. All right, for this next problem, we have an isosceles triangle. And it says that the base angles have the same measure. It's telling you that one of them is 36. So what are the other two angles? Well, the other one would be 36 here. So that's one of them. And then I need to figure out the third angle. So I'm going to have x plus 72 is equal to 180. Subtract 72. And x is equal to 108. So the other angle is 108 degrees. Done. All right, for number 11, state the congruence relations for triangle PQR and triangle XYZ. Well, we have 50 here, right? Those are congruent. These are congruent. These sides are congruent. Well, we could say the triangles are congruent by AS, or you could solve for the missing angle, which is 60. Right? And you could say the triangles are congruent by ASA. ASA. All right, so either way, both of those shortcuts work. All right, if line LO is the angle bisector of angle MLN, okay, it bisects this angle, bisects this angle. By which postulate can we prove that LOM is congruent to LON? Okay, so we have the angles are bisected. We know those are congruent. I have right angles here are congruent. All right, then I know that both of the triangles share this side in common. So I can say that the triangles are congruent by A, S, A. All right. A, S, A, S, A. All right, that's it. In the figure shown, measuring angle T is equal to measuring angle V, and E is the midpoint of TV. E is the midpoint of TV. All right, so these are the same. What congruent statement would prove triangle TER is congruent to triangle VEC? Okay, well, I know these are vertical angles here, so I can say the triangles are congruent by ASA. ASA. All right, same shortcut again. Next one. All right, in the figure shown, IN is equal or congruent to CK, and IK is parallel to NC. What congruent statement would prove that these triangles are congruent? Well, since the lines are parallel, I know these are alternate interior angles, and they are congruent. Okay, here we have the reflexive property, but then we end up with ASS, and that doesn't work. So I can't say that they're not congruent, but I will say that there's not enough information. Now, on the key, it says SAS, and I don't see how you could use SAS in this problem, or maybe I'm missing something, but there's not enough information from what I'm seeing right now. Okay, so the key's wrong. Going to the next problem. Name a segment that is a median of the given figure. All right, what does it mean to be a median? All right, it means a line that's coming across the triangle and then hits the side at its midpoint, and it bisects it. So this red line here, that's a median. So name the segment. You could say EB, oops, or you could say BE. Could order the letters however you want. All right, done with that. All right, name a segment that is an altitude of the given figure. Okay, here's an altitude going from one angle and then going straight down. Sometimes the altitude will land inside the triangle. In this case, it lands outside the triangle, right? So your altitude is BC or CB. Done. All right, in triangle DOG, measurement of angle O is 48. Measurement angle G is 25. Which side of DOG is the longest? All right, so I'm going to draw a triangle DOG. All right, O is 48 degrees. G is 25 degrees. D is going to be what? We'll subtract 48 25 from 180, and we get 107 degrees. All right, so which side of the triangle is the longest? Well, here's the largest angle, so across from it would be the longest side. So we would say OG over GO. Done. All right, in triangle PIG, all right, P is 82 degrees, G is 33 degrees. What is the shortest side? Okay, so I subtract 82 and 33 from 180, and I get 65 degrees. Okay. And which angle is the smallest? 33. So across from that would be the longest side. So PI or IP. All right, on to the next. What is the name of the polygon, the sum of whose angle measures is 720? Okay. And I think they're referring to the interior angle measures. So n minus 2 times 180 is your formula for the sum of the angles of a polygon. In this case, it's 720. So I'm going to divide by 180. I get n minus 2 is equal to 4, and then I add 2. So n is equal to 6, and if a polygon has 6 sides, then it is a hexagon. Done. All right, find the measure of one of the angles of a regular polygon whose angle sum is 2,340 degrees. All right, find the measure of one of the angles. All right, so this is the formula for all of the angles. So there we go. Now I'm going to figure out how many sides it has. So I'm going to divide by 180. And I get n minus 2 is equal to 13. Then I'll add 2, and I get n is equal to 15. All right, now I want to figure out the measure of each angle. So I'll use the formula now, n minus 2, 15 minus 2, times 180, divided by n, which is 15. So I have 13 times 180 divided by 15. So I have 13 times 12, which is 156. Oh, 156 degrees. Done. All right, in the parallelogram, EFGH. All right, it's a parallelogram. Let's label it. If measurement angle E is 8x plus 6, and G is 5x plus 18, find measurement of angle H. Okay. All right, well, I know that these two angles are equal to each other. All right, solve for x. So x is equal to 4. All right, now if I want to figure out measurement of angle H, I know measurement of angle H plus these two angles combined add up to 180. 8x plus 6 is equal to 180. All right, so I'll have measurement of angle H plus 8 times 4 plus 6 equals 180. Measurement angle H plus 32 plus 6 equals 180. Measure angle H plus 38 equals 180. Subtract 38. And I get 142. All right, there's my answer. All right, on to the next problem. In parallelogram EFGH, all right, F is 10x minus 3. And one thing to take note of is that when you're labeling the diagram, walk around it. If you don't do that, you could easily throw off the whole problem. All right, and G is 8x plus 21. They want to know what F is. Okay, so I know that these two angles combined, they're consecutive interior, they add up to 180. Alrighty, so I have 18x plus 18 equals 180. Subtract 18. I get 18x equals 162. Divide by 18. And x is equal to 9. I'm not done yet. Make sure you answer the question. All right, so measure angle F is equal to 10x minus 3. So I have 10 times 9 minus 3. So I have 90 minus 3. So I have 87 degrees. Measurement of angle F. Done. All right, if ABCD is a rhombus and AB is 27, it's a rhombus. All the sides are the same. AB is 27. What is AD? Well, AD must also be 27. That was really easy. Done. All right, if the diagonals of a rhombus have lengths of 18 and 24, all right, have a rhombus. All right, this diagonal length is 18. This diagonal length is 24. Let me actually redraw this diagram. All right, if one diagonal length is 18, I know that diagonals bisect, so I'll call each of these 9, and for the other one I'll call each part 12. All right, that's better. All right, what is the length of the perimeter of the rhombus? Okay, so here I have 9, 12. What is the other side going to be? It's going to be 15. How do I get that? Pythagorean triples. This is 3 times 3, 3 times 4, 3 times 5. Or use the Pythagorean theorem. So all the sides have the same length. 4 times 15 is my perimeter. So the perimeter is 60. It's going to be 60 units. Done. All right, in the figure, IJKL is an isosceles trapezoid. All right, with base LK, and JKL is 63, JKL 63 degrees. Find LIJ, this angle. Okay, so if that's 63 degrees, this over here is 63 degrees because it's an isosceles trapezoid. And I know that these angles here are supposed to add up to 180 because they're consecutive interior. So subtract 63, and measurement of angle LIJ is equal to 117 degrees. Done. All right, in the figure, IJKL is an isosceles trapezoid. Okay, IJKL. Let's see here. With bases, all right, ILK. This angle here is 100 degrees. It's an isosceles trapezoid. Find LKJ. Okay, well, it's an isosceles trapezoid, so the base angles are congruent. Measurement of angle LKJ is simply 100 degrees. Done. Which of the following statements must be true? All congruent triangles are similar. Well, this is definitely always true. All right, if you have two triangles that are congruent, they're similar. They're always going to be. Their ratio is 1 to 1. All right, for part 2, all similar triangles are congruent. No, here's two similar triangles. But do they overlap perfectly? No, they're not the same size. They're not congruent. That's not always true. All right, and all right triangles are similar. Here's a right triangle. Here's another right triangle. Are they similar? No. Sometimes they will be though, but not always. All isosceles right triangles are similar. Isosceles right triangles. They are similar. Yeah, they're going to have the same structure. All right, one is just a blown up version of the other. So 1 and 4. Those options must be true. All right, on to the next example. Here's a list of different types of triangles. Acute, scalene, obtuse, right, equilateral. Triangles of which type are always similar? Interesting. All right, you can have triangles that are acute and they have different angle measurements. You could have triangles that are scalene and have different side lengths where the ratios aren't equal. You can have obtuse triangles where the obtuse angles aren't the same. You could have right triangles where the other angles are not the same. Equilateral triangles. Yeah, for equilateral triangles, the measurements are always 60 degrees for the angles, right? So just by AA alone, you know that they always have to be similar. So just option 5, that's it. Done. All right, in the diagram shown, OP is parallel to LN. All right, these are parallel here. All right, if MO equals 3, MP equals 4, ML is 9, they already put that on the diagram for us. What is the length of PN? So if I want to figure out PN, how am I going to do that? Well, I know that these triangles are similar by AA. So I'm going to set up a proportion. 3 corresponds to 9, and 4 corresponds to 4 plus PN. And now I could solve for PN. So I'm going to cross multiply. I have 36 equals 12 plus, don't forget to distribute, 3PN. Subtract 12. I have 24 is equal to 3PN. Divide by 3. And PN is equal to 8. And it's going to be, yeah, that's it, 8 units. Just say PN is equal to 8. Done. All right, in the accompanying diagram, AB is perpendicular to AD, and EC is perpendicular to AD. All right, I have that labeled for us already. If AB is 6, let's label for us. EC is 4, and ED is 8. Find AE. All right, got to find this length here. All right, so I'm going to focus in on this blue triangle and focus in on the green triangle. All right, so for the blue, I have 8 corresponds to what for the bigger triangle? AE plus 8. And then I have 4 for the smaller triangle. That corresponds to 6 for the bigger triangle. All right, so I have my proportion. I'm going to cross multiply. I'm going to simplify this side, 2/3. So I have 24 is equal to 2 times AE plus 16. I'm going to subtract 16. And then I have 8 is equal to 2AE. Divide by 2. And AE is equal to 4. Done. All right, triangle ABC is a right triangle. All right, ABC is a right triangle. Which equation could be used to determine the length of side AC? We could just do this. Could do x squared plus 7 squared equals 20 squared. Then you could subtract 7 squared. Square root both sides, and they just left it without simplifying everything, all right, in the answer key. So just be aware that maybe on the multiple choice test you'll get something like this. All right, that's all there is to that. All right, if C is 9, X is 4, which formula would you use to solve for Y? All right, so you have 4 squared plus Y squared is equal to 9 squared. All right, so we're going to subtract 4 squared. So Y squared is equal to 9 squared minus 4 squared. Square root both sides, and I have Y is equal to square root of 9 squared minus 4 squared. All right, that's number 32. And for the answer, they left it like this. So a little odd, but as long as you're doing the math correctly, everything should line up fine. All right, so they don't want you to solve for Y. They just want you to find the equation that allows you to solve for Y. All right, moving on to the next problem. All right, to get to school, Lydia drives 8 miles south, turns and drives 6 miles east. If she could drive in a straight line, how many miles would she save? All right, so essentially, it's if she drove the hypotenuse, how many miles would she save? All right, so you could use the Pythagorean theorem, but in this case, we notice that there is a Pythagorean triple. All right, so that's 10. 10 miles. Done. Oh, before I complete this, I didn't follow the directions. All right, so it says how many miles could she save? All right, her normal route is 14 miles. And the route that I just figured out is 10, so you would save 4 miles. That is answering the question. All right, to get to work, David drives 30 miles north, turns and drives 60 miles west. If he could drive in a straight line, how many miles could he save? Okay, so adding these two together, it's 46 miles. All right, so let's figure out the new route. All right, you could do 16 squared plus 30 squared equals x squared. All right, but also there is actually a Pythagorean triple in disguise here. There's one that's not used too often. It's the 8, 15, 17 Pythagorean triple. So this is 34. And then you get 12. All right, but you could do all the work here too. But eventually you'll just end up with x is equal to 34. All right, going on to the next problem. Solve for A. Okay, we have a right triangle here. This is 60, so this must be 30. And this is the short leg. All right, everything revolves around the short leg, so I'm going to call this X. So what do you do to the short leg to get the long leg? You multiply it by square root of 3. All right, so I need to solve for X now. All right, so X is equal to 10 over square root of 3. And we'll rationalize the denominator. Okay, so that's what x is. Now, once I have x, what do you do to it to get the hypotenuse? I'm going to multiply it by 2. So I'm going to get a is equal to 20 square root of 3 over 3. Done. Find the exact value of y. Okay, I have 90 degrees here. That's 45 degrees. So this is an isosceles right triangle. That's y as well. All right, so for 45, 45, 90, what do you do to the leg to get the hypotenuse? You multiply by square root of 2. And then you get the hypotenuse, 6. So I divide by square root of 2. I'm going to rationalize the denominator. So I get 6 square root of 2 over 2. I have 3 square root of 2 for y. Done. Find the exact value of y. All right, here it's 45, 45, 90. That's y. I have an isosceles isosceles triangle here. And I'm going to take y, multiply it by a square root of 2, and that gives me the hypotenuse, which is square root of 6. All right, so now I'll divide by square root of 2. All right. And square root of 6 divided by square root of 2 is the same thing as this, which is that. All right. So you could rewrite it as a square root of the whole fraction, 6 over 2. So y is equal to the square root of 3. Done. All right, determine the value of x in the diagram. All right, this is the short leg. So I take the short leg, I multiply it by square root of 3, and I get the long leg. Now I'm going to divide by square root of 3. All right, so there's my short leg. And what do you do to that to get the hypotenuse? I don't need the hypotenuse. I solve for x. I'm done. There we go. All right, so there's 38. Express sine of A as a ratio of the lengths of the sides of A, B, C. Okay, so sine of A is equal to, here's A, it's opposite, so it's BC or CB, over the hypotenuse, which is AB. Alrighty, done with that. Alright, express tangent of A as a ratio of the variables given. Alright, so I have A here. Tangent is opposite, which in this case is lowercase a, over adjacent, which is lowercase c. Done. Alright, which of the following statements is incorrect for the given diagram? Alright, sine of S is opposite over hypotenuse. That works. All right, cosine of S is 4 over 5. Of S is 4 adjacent 4 over 5. Yeah, that works. That's fine. All right, then we have tangent of P. Tangent is opposite, which is 4 over adjacent, which is 3. All right, then we have tangent of S, which is opposite 5. Oh, there's one that's wrong. And triangle PRS is a right triangle. Yeah, it's 3, 4, 5. Satisfies the Pythagorean theorem, so it's a right triangle. So D is incorrect. Done. Which of the following statements is incorrect for triangle ABC? All right, here I have angle A. All right, and opposite is supposed to be A, so that one's incorrect. All right, so I know, what about cosine of C? Cosine of C is adjacent, which is A, over hypotenuse, which is B. That's good. Then I have tangent of A. Tangent of A is opposite, which is A, over adjacent, which is C. That one's good. A squared plus C squared equals B squared. A squared plus C squared equals B squared. Yeah, that satisfies the Pythagorean theorem. Okay, that's set up right. And then tangent of C. Tangent of C. Opposite is C over adjacent, which is A. Yeah, that checks off. Okay, these are all good. So A is the only incorrect answer. All right, in right triangle ABC, measure angle C equals 90. Measure angle A equals 63, and AB is 10. All right, if BC is represented by A, then which equation can be used to find A? Okay, so I would say sine of 63 is opposite over hypotenuse. Yeah, A. Tangent of 63 opposite over adjacent. That doesn't work. They got A equals tangent of 27. That's not going to work at all. All right, and then I have A over 10 for cosine of 63. All right, so adjacent is CA. It's not lowercase a, so that doesn't work. So it's just A. All right, with a given triangle, which trigonometric ratio can be used to find the hypotenuse? I want to find this here. Okay, so sine of 40 is opposite over hypotenuse. There's two missing pieces of information there. That doesn't work. All right, then I have cosine of 40. That's going to be adjacent over hypotenuse. Yeah, that works. I have enough information there. Then I have tangent of 40. Tangent is opposite over adjacent, but I'm looking for the hypotenuse. So that's not going to work. Same thing here, tangent. Then cosine of 50. Where's the 50 from? Over here. And that's adjacent over hypotenuse. There's two missing pieces of information there. That's not going to work. So it's just B. Done. All right, in the triangle, what is the measure of segment QR? Here's segment QR. What is the measure of QR? All right, in this case, what will you have to use? You will have to use this angle measurement here, which is 50 degrees. And then I could use the law of sines. So it's going to be sine of 50 over QR, which is equal to sine of 70 over 5. All right, so solving for QR, what do you get? So I'm going to have 5 sine of 50 is equal to QR times sine of 70 divided by sine of 70. Alright, so that's it then. Done. Alright, a triangle has sides of lengths A, B, and C. Then according to the sine law, what does B equal? Alright, so I call these angles ABC, and then that would be A, that would be B, and that would be C. Alright, now there's so many different ways to write this out, but let's go with the A's and the B's. So sine of A over lowercase a is equal to sine of B over lowercase b. So if I'm solving for B, I'm going to cross multiply here and have B sine of A is equal to A sine of B, and I'll divide by sine of A. So this is just one example of a correct answer. Alright, that's all there is to it. We're done. Alright, using the figure shown, which line segment could represent a chord of the circle? Which could represent a chord? This is a radius, that's a radius, this is a chord right here. MN. That's all there is to it. B. Done. Alright, using the figure shown, which line segment could represent a chord of a circle? Okay, that wasn't very difficult at all. That's a radius. This would be a chord from one point of the circle to another. ML or LM. Alright, so 48 is just C. Done. Alright, given circle O with measurement of angle ROQ is 150 degrees, find measurement of PR. Okay, if that's 150, then this is 30 degrees, and the central angle has the same measure as the arc, PR. So measurement of arc PR is equal to 30 degrees. Done. Alright, given the following figure with measurement of AD is 50 degrees, the arc is 50 degrees, CB is 110, and AB is a diameter. Alright, find DCB. Okay. Alright, so let's see what I'm going to do here. Alright, since this is a straight line, this is 110 degrees here, so that makes this 70 degrees, so that's 70. So the arc measure that I'm looking for is 50 plus 70 plus 110, which is 230. Done. Alright, find the shortest distance from the center of the circle to the line RS. Alright, that's a perpendicular distance, and it bisects the chord. So if the whole chord length is 8, then each part is 4. And it says that the diameter is 20, so the distance from here to R is going to be 10. Alright, so now I just use the Pythagorean theorem to solve for x. So I have x squared plus 4 squared equals 10 squared. X squared plus 16 equals 100. Subtract 16. X squared is equal to 84. Square root both sides. I have 2 times 42, 2 times 21, 3 times 7. I have a pair of 2's, so x is equal to 2 square root of 21. Done. Alright, suppose the chord of a circle is 6 centimeters long. I have to draw a circle. The chord is 6 centimeters long and 4 centimeters from the center. Alright, so the distance from the chord to the center, that's a perpendicular distance, that's 4, and that bisects the chord. How long is the radius of the circle? Alright, so the radius is from here to that point. So since the chord is bisected, this length is 3, this length is 3, so now I have a 3, 4, 5 triangle. The radius is 5. That's all there is to that. Done. In the figure, angle PQR is inscribed in the circle O, and PQR, angle PQR is 28 degrees. Alright, what is the measure of arc PR? So all you have to do is double the angle measurement to get the arc measure. That's a R. Alright, so it's equal to 2 times 28, which is 56 degrees. Done. Alright, given the picture with diameters RT, SU, and measurement of angle RPU, 143, find measurement of arc RSU, this whole arc here. Okay, let's see what we're going to do here. Well, this is 143 here, this arc measure, because that's a central angle. It says that they're diameters, so they must intersect at the center. And I'm just going to take 360 and subtract 143. So I end up with 217, which is the rest of the arc measure. Alright, that's all I have to do for that. Done. In the figure, RT and SU are diameters. RT and SU. What is the measurement of RTU? Alright, I should have used the diagram from the previous problem, but this still works. So RSU RSU, this is 65 degrees, and that's an inscribed angle, so this arc measure here is 130 degrees. They want me to find RTU, this arc measure. So I take 360 and I subtract 130. So I get 230 degrees. Done. Alright, in the figure, ABC is inscribed in a circle. Oh, which of the following is true? Okay. Measurement of angle AOC, this angle here, is equal to ABC. No, one's a central angle and one's an inscribed angle. That can't be. Alright, AOC is equal to half of the measure of angle ABC. Alright. No, if I take half of this angle measurement, no, it's supposed to be double, so that's not going to happen. Oh, here's double, so this one's going to work. Yeah. And then I have arc AB is equal to arc BC. I don't think you can say that that's true for certain. And 4/5, I don't know where the 4/5 is coming from. Yeah, I can't do that one either. So C is the correct answer. On to the next problem. Alright, in the circle shown, chords AC and BD intersect at E. AE is 8. Label your diagram. BE is 4. How long is DE? Okay. So I know the formula is this for when chords intersect in a circle. It's going to be 8 times 6 is equal to 4 times DE. So I get 48 is equal to 4 DE. Divide by 4. And DE is equal to 12. Done. Alright, in the diagram, chord AC bisects chord BD. Yeah, okay, so essentially these are the same. Even though it doesn't look that way, they're the same. Alright, so AE is 7, EC is 4. What is the length of BD? Alright, they're the same, so I'll call both of these X. Alright, so here's the formula again for two chords that intersect. It's going to be 7 times 4 is equal to X times X. So I have 28 equals X squared. Square root both sides. I have 2 times 14 and 2 times 7. So X is equal to 2 square root of 7. They're not asking for what X is. They're asking for what the whole length is. So essentially I have to multiply this by 2 or add it to itself. So BD is equal to 2 times 2 square root of 7, which is 4 square root of 7. Done. All right, determine the center of the circle if the endpoints of a diameter are 6, -3, and -4, 7. All right, determine the center of the circle. The endpoints of the diameter are 6, -3, and 4, -7. So essentially I'm going to be using the midpoint formula here. All right, because you have a circle, diameter, they give you the endpoints. I want to find the center of the circle, so that would be the midpoint of the diameter. So using the midpoint formula, I have 6 plus -4 over 2, and then I have -3 plus 7 over 2. So I end up with 2 over 2, and I have 4 over 2. So I end up with 1, 2 for my coordinates. Done. Alright, circle has center 2, 3 and radius 5. Alright, this is your HK. Which of the following points is on the circle? Okay, so x minus h, here's the equation for a circle, 2 squared plus y minus k equals r squared. So 5 squared, which is 25. So there's the equation I will be using. I need to test out all these values. Alright, plug them in. Does the equation work out to be true? Plug it in. Does the equation work out to be true? Plug it in. Does the equation work out to be true? So if you do that with all 5, the only one that works is D. Done. Alright, what is the equation of a circle having radius 1 and center 1, 2? Alright, here's your center, that's your radius. So I have x minus h, which is 1 squared, plus y minus k, k is 2, and then r squared, so I have 1 squared, which is just 1. And I can't simplify this equation anymore. I am done. Alright, AB is the diameter of a circle whose center is -2, 2. Alright, diameter of a circle, center is -2, 2. If point A, this is AB, if point A has coordinates 2, -3, what are the coordinates of point B? Alright, this goes all the way back to chapter 1, but they're relating it to a circle. So here's the midpoint formula. Well, first of all, here's the midpoint, -2, 2, and then that's equal to the sum of the endpoint values divided by 2. So I have 2 plus x sub 2 divided by 2, and then I have -3 plus y sub 2 over 2. Alright, and I have to solve each of these equations. So I have -2 is equal to that. Let's solve it now. Alright, got that. Then I have the next one. So I have 2 is equal to -3. Alright, so I'll multiply by 2 on both sides again. These cancel out. So I get 4 is equal to -3 plus y sub 2. I'm going to add 3. 7 is equal to y sub 2. Okay, so then my point B, the coordinates of it are -6 and 7. Done. Alright, find the radius of a circle with a circumference of 3x. Radius, the circumference, is 3x. So 3x is equal to 2 pi r. Find the radius of a circle with a circumference of 3x. So I just divide by 2 pi. There's nothing else we could do here. It's just 3x over 2 pi. Done. All right, find the diameter of circle with circumference of 9. Circumference is twinkle, twinkle, little star. Circumference equals 2 pi r. All right, so I have 9. Then I divide by 2 pi. Okay. All right, well, diameter is equal to 2 times r. So r is 9 over 2 pi. The 2's cancel out. I'm just left with 9 over pi. Done. That's my diameter. A square is inscribed inside a circle. Circle, square inside. All right. With a radius of 10, so the radius is going to go to the corner. That's 10. What is the area of the square? All right, so I'm going to have a 45, 45, 90 inside of this square. And I multiply the leg by square root of 2 to get the side length of the square. Now, to figure out the area of the square, I multiply the side lengths, which are both the same. So I get 100 times 2, which is going to be 200. In this case, centimeters squared. Done. All right, square is inscribed inside of a circle. Once again, square is inside of a circle. All right, what is the area of the square? All right, diameter is 10, so the radius must be 5. All right, so same deal as before. This is a 45, 45, 90. All right, so this is 5 square root of 2. So the area of the square is 5 square root of 2 times 5 square root of 2. So it's 25 times 2. Area is 50, in this case, centimeters squared. Done. All right, if r is equal to 34, what is the area of this sector? Express your answer. All right, this is just a quarter of a circle. So a is equal to 1/4 pi r squared. So I have 1/4 of 34 squared. Okay, so the important thing is that you know how to set it up properly. And once you punch it in your calculator, around the decimal to the nearest tenth, it's going to be 0.9. And we have centimeters squared. Done. We could have also done this for the problem. Let's make sure we know how to set it up for any angle measurement. So it'd be 90 over 360 is equal to the area of the sector over pi r squared, the area of the whole circle. So that would actually be the setup, all right, for any angle measurement or a sector with any angle measurement. All right, just want to make sure you know that much. All right, so here we have 270 degrees for this sector over the total measurement, which is 360, and then I have area of sector over the total area, which is pi r squared. All right, so this reduces to 3/4. I have 3/4 is equal to a sub s over 144 pi, cross multiply, and I get 432 pi is equal to 4 a sub s. So I divide by 4, and a sub s is equal to 108 pi. And if I plug in pi and I round it, I get 339.3 centimeters squared. All right, the lengths of the diagonals of a rhombus are 7 and 16. What is the area of the rhombus? All right, rhombus. All right, diagonals, so this would be like 3.5, and that would be 3.5, and that would be 8, and that would be 8. All right, what is the area of the rhombus? Okay, what is the area? Okay, so area is equal to half of d1 times d2. Half of d1, which is 7, and d2, which is 16. So I have 8 times 7 equals 56. Or in this case, it's going to be units squared. Done. Alright, if a rhombus has diagonals with lengths 8 and 2x minus 3 and an area of 36, find the length of the other diagonal. Alright, rhombus. Diagonals with lengths 8 and 2x minus 3 and find the length of the other diagonal. Okay, so the area formula is half diagonal 1 times diagonal 2. So I have half of diagonal 1, which is 8, and diagonal 2, which is 2x minus 3. And the area is 36. Alright, so I have 36 equals 4 times 2x minus 3. Divide by 4. I get 9 equals 2x minus 3. Add 3. And I have 12 is equal to 2x. Divide by 2. And x is equal to 6. Alright, take that and I plug it in here. And that gives me the length of the other diagonal. So diagonal 2 is equal to 2 times 6 minus 3. So 12 minus 3, which is 9. Alright, that's all there is for that one. Alright, if each side of a regular hexagon measures 5 inches, find the area of the hexagon. Okay, we have a hexagon. Each side is 5 inches. Alright, and for a hexagon, inside of it are 6 equilateral triangles. Alright, so this is 5. Now I just have to figure out the area of each triangle. I'm going to cut it in half here. So this is 2.5, and this is going to be 2.5 square root of 3. Okay. So let's figure out the area of the triangle, which is equal to half. The base of the triangle is 5 times the height is 2.5 square root of 3. Alright, we'll rewrite 2.5 as a fraction, so 5 over 2. Alright, so if I multiply all these, I get 25 over 4. Alright, so we're not dealing with any decimals in this case. And then, so the area of the hexagon is 6 times the area of the triangle. So 25 over 4 square root of 3. Alright, so from this I get 2 and 3, so I get 75 square root of 3 over 2. Alright, that's for 71. And this is inches squared. Done. Alright, find the area of a regular hexagon with a side of length 8. Alright, here's a hexagon once again. And I can divide the hexagon into 6 equilateral triangles. Let's figure out the area of one of them. Alright, this is 8. Let's cut the triangle in half. So this is 4. This is 4 square root of 3. The area of the triangle is half base, which is 8, times height, which is 4 square root of 3. So 16 square root of 3. So the area of the hexagon is 6 times the area of the triangle, which is 16 square root of 3. So it's going to be 96 square root of 3 for the area. Right? Units squared. Already done. The volume of any geometric pyramid or cone can be found by... Okay, well, how can you find it? Pyramid and cone, what's the relationship? Can be found by multiplying the area of the base by and then multiplying by the height. Alright, there's different ways to describe it, but that's the general idea. Alright, a prism has a height of 5 centimeters and a base of 44 centimeters. What is the volume of the prism? Alright, so volume of a prism is area base times the height. They give us everything we need. Alright, an empty swimming pool is 2 yards deep, 10 yards wide, and 25 yards long. How many cubic yards of water would it take to fill the pool? Alright, so swimming pool, 2 yards deep, 25 yards long, 10 yards wide. So area of the base is 10 times 25, which is 250, times the height, which is 2. Alright, and then I have yards cubed. Done. Alright, an empty swimming pool is 3 yards deep. Alright, 15 meters long, 5 wide. Okay, so the volume is 5 times 15, which is 75, and the height is 3. So you have 225 yards cubed. Done. A box measures 7 centimeters width, 12 centimeters in length, and 3 centimeters height. The height is tripled to 9 centimeters to produce a larger box. Which phrase accurately describes the volume of the second box in relation to the first box? Okay, so for the first box you have 7 times 12 times 3. Right? Right, but for the next box, what's happening to the height? You're tripling it. So essentially you've multiplied by 3, right? So by multiplying by 3, you've increased the volume 3 times. Right? Just analyze what's actually going on with the numbers, and it's not too difficult to answer the problem. If the length, width, and height of a rectangular prism were each doubled, what would happen to the volume of the rectangular prism? Alright, so if you had a prism, and you had x, well, let's just do it like this. Let's just do it like this. Length, width, height. If those were all doubled, what would happen? Those were all doubled. What would happen to the volume? Alright, here's the volume of the first prism, just length times width times height. Here's the volume of the second prism, 2L, 2W, 2H, which gives me 8LWH. So the volume would increase, what, 8 times. So to answer this question, you would write 8 times larger. That's how much the volume would increase by. Alright, the volume of a cone is blank the volume of a cylinder with the same base and height. Alright, so it's just 1/3. Alright, that's all there is to that. The volume of a cylinder is blank times the volume of a cone with the same base and height. Okay, so they're just going backwards. So if you multiply by 1/3 of the area of a cylinder to get a cone, you would multiply by 3 to go from the area of the cone back to the cylinder. Alright, to the nearest tenth of a square centimeter, what is the surface area of the cone if the radius of its base is 5 centimeters? 5. And its height is 12. Okay, what is the surface area? Okay, I need to figure out the slant height, so nice that I have a 5, 12, 13 triangle here, or just use the Pythagorean theorem. So the surface area of a cone is pi r squared plus pi r l. So I'm going to have pi 5 squared plus pi 5 times L, 13. So I have 25 pi plus 65 pi, and that's equal to 90 pi. If I plug in pi, I end up with 282.7 centimeters squared. Done. Alright, find to the nearest square centimeter the surface area of the figure. Alright, here I have 2 times 3. This is 2 times 5. This is going to be 2 times 4. So 8. Alright, so to figure out the surface area of this, once again, using the surface area formula, I'm going to have pi r squared. R is 6 plus pi 6 times 10. Alright, so I have 36 pi plus 60 pi, which gives me 96 pi. I actually didn't need to figure out the height for this problem, but still good to know. So if I multiply 96 by pi, I get 302 centimeters squared. Done. Alright, an ice cream cone which measured 12 inches high and had a base with a radius of 1.5 inches was filled with chocolate pudding. Which formula would you use to determine the volume of pudding that the ice cream cone can hold? Which formula? They just want to know the formula. Okay, whatever. Alright, so it's 1/3 area of the base times the height. So you would have, this is a cone. So you're going to have 1/3 area of the base, which is pi r, which is 1.5 squared, times the height, which is 12. Okay, so they do something a little funky in the key. They just sort of simplify this expression. So they divide 3 into 12, and they get 4. And then they write everything out. They expand it. 3.14, 1.5 times 1.5, that's 1.5 squared, and then times 4. Why they write it out that way, I don't know, but that gives you the volume. So if you're doing a multiple choice problem, that's what you'd be looking for. Alright, a pile of sand dumped on a driveway is in the shape of a cone. 3 centimeters high. And 5 centimeters in diameter. So that's 2.5 there. What is the approximate volume of sand? So volume is equal to 1/3 area of the base pi 2.5 squared times the height. So those cancel out. And 2.5 squared is 6.25 pi times pi, which is 19.6. It's going to be meters cubed. That's the volume. Done. What is the surface area of this sphere if r is equal to 6? So you just plug it in. Make sure you take 6 squared first. And then you have 4 times 36, which is 144 pi. And they want you to plug pi in, which gives you what? On this problem, just leave it in terms of pi. Alright, that's it. They should be more clear with what type of answer they want, if they want it in terms of pi or they want it as a decimal. Okay, but there it is. Same answer as what you have in the back of the packet. Going on to 6. What is the surface area of the sphere if r is equal to 7? Answer accurate to 1 decimal place. Alright, so it's not in terms of pi. We have to round the decimal. Okay, so we have the surface area formula for pi r, which is 7 squared. 4 times 49 is 196. And if we multiply that by pi, we get 615.8 centimeters squared. Alright, done. All right, find the volume of this sphere. D is equal to 8. So the radius is 4. Let's plug that in. All right, don't forget to cube. A lot of students are in the habit of squaring and they forget to cube. So make sure to do that. So we get 64. And then we have 4 times 64, which is 256. Ooh. Over 3 pi. That's a 5 right here. 5. Okay, 256 pi over 3. Done. And it's just units cubed. All right, to the nearest tenth of a cubic centimeter, what is the volume of the sphere? Radius 7. So 4/3 pi 7 cubed. All right, so working this all out, make sure you cube this piece first. We get 1,436.8 centimeters cubed. That's our volume. Done. All right, which of the following will map ABC onto A prime, B prime, C prime? Okay, so what's happening here? So A goes to A prime, C goes to C prime, and B goes to B prime. All right, that looks like a rotation of 90 degrees counterclockwise. All right, that's all there is to it. There's also a formula you can apply in this particular case, but if you just understand things visually, then you don't even need to know the formula. You'll just see that it's a 90-degree rotation. All right, what are the coordinates of the point which is the reflection in the y-axis of the point whose coordinates are 5, -3? All right, so we have a coordinate grid here. We have 5, -3. All right, what are the coordinates of the point which is the reflection in the y-axis? This is the y-axis here. It's being reflected. So it ends up here. And so the x value changes to -5. And the y value is -3. Done. All right, the points 2, 3, and 5, 1 are reflected over the y-axis. Find the number of square units in the area of the quadrilateral's vertices are the points and their images. Okay. All right, so I have 2, 3. Then I have 5, 1. Okay. Reflecting over the y-axis, so I'm going to be over here. Okay, so that's an isosceles trapezoid. And the area of this would be half of the height, which is just 2 units, times base 1. Base 1 is 10 units, times base 2, which is 4 units. Or sorry, plus, which is 4. So it's going to be half of 2, which is 1. 10 plus 4 is 14. Yep, that's it. 14 units squared. Done. Okay, now for the proofs. Alright, so here's my statement. Here's my reason. Alright, so 1, M is the midpoint of Pn. M is the midpoint of Pn. Alright, that's given. Make sure to label the diagram based off of that information. Pn. Alright, Pk is parallel to Qn. Okay, that's given. All right, and PK is congruent to QN. PK is congruent to QN. Okay, now let's see what we can do here. All right, now I could say PM is congruent to MN. All right, well, they told me it was the midpoint, so now I know these segments are congruent by definition of midpoint. Then the lines are parallel, so I could say that these are congruent. Angle P is congruent to angle N. So that's alternate interior angles. They're congruent. And now I can say that the triangles are congruent. By what reason? SAS. SAS. Done. All right, once again, another proof. Statement. Reason. All right, first statement. GM is congruent to GK. That's given. 2. JM is congruent to JK. All right, that's given. All right. So let's label the diagram. GM, GK, JM, and JK. All right, HK is congruent to HM. How am I going to figure that out? Okay, well, you know that GJ is congruent to GJ by reflexive property. All right, so I'm going to put it like in between here. All right, so you know that these two triangles are congruent then. I know that triangle GKJ is congruent to triangle GMJ. Okay, and that's by SSS. All right, now how does that help us? All right, because I know that, now I could say that these angles are congruent. Okay, angle KJH is congruent to angle MJH. Okay, how do I know that? Well, I just proved that the triangles are congruent, so the corresponding angles corresponding parts of congruent triangles are congruent. Okay, now that I know that, I could say HJ is congruent to HJ. That's by reflexive property. All right, so I'm going to do this here. Okay, and then now I could say that these two triangles are congruent. KHJ is congruent to triangle MJH. Okay, and that's by SAS. Check that out. All right, now that I know those triangles are congruent, I could say that these sides that correspond for them, they're congruent. So HK is congruent to HM, and that's by CPCTC. Okay, if you're able to do that on your own, you got some geometry proof skills, which I do. Okay, but it's good for you to know how to do all this and understand it. The proofs on the test won't be this complicated, but you definitely need to understand all these reasons. All right, so statement, reason. 1, angle 1 is congruent to angle 2. That's given. Make sure to label the diagram. All right, and then AJB is congruent to angle BKA. That's given. All right. Make sure to label the diagram. All right, so look at this. I have this triangle here. It has two angles that are congruent to this triangle here. I'm trying to prove that these are congruent, and they share this side in common. AB is congruent to AB. That's by reflexive property. All right, so the triangles then are congruent by what? AAS. 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 Done. All right, in the diagram, if lines A and B are parallel, which of the following must be true? Alrighty, well, there's no answer choices here. So let's just understand this. These are what? Corresponding angles. These are what? Consecutive interior angles. Well, corresponding or equal. Consecutive interior add up to 180. These are what? Alternate interior angles. These are what? Alternate exterior angles. These are what? Vertical angles. These are what? They're a linear pair. All right, make sure you know all those relationships. Going on to the next problem. All right, lines R and S are cut by transversal as shown. If you know that the lines are parallel, then which of the following angle pairs must be supplementary? Which one are supplementary? 1 and 4. Those are equal. 3 and 5. Those are definitely supplementary. 1 and 6. Those are supplementary as well. All right, because these are corresponding here. So, and then these add up to 180. And then 2 and 8. 2 and 8. Yeah. These are equal to each other here. So, and these add up to 180. So, 2, 3, and 4 would be the options that work. Done. All right, if the angles of a triangle are represented by x, 3x plus 20, and 6x, the triangle is, all right, I have x, I have 3x plus 20, I have 6x. If I add all these up, what do they add up to? Alright, I'm going to plug this in and we'll work it out. So here's the angle measurements for the triangle I get. 96, 68, and 16. Alright, what type of triangle is this? Well, it has an angle that's greater than 90 degrees. That makes it obtuse. That's not an option here. It's definitely not right. It's definitely not acute. It's definitely not isosceles. All the angles have different measures, so all the sides must have different lengths, which makes it scalene. Done. All right, which type of triangle is triangle ABC? All right. Well, I know that these two angles add up to be equal to the exterior angle. You have to know that relationship to solve this problem. All right, so I take that value and I plug it in here, and let's see what I get for the angle measurements. I get 40 degrees, then I get 40 degrees, and here I get 80 degrees. So this is 100 degrees right here. All right, so what type of triangle is it? Well, two angles have the same measure. These sides are the same. It must be isosceles. All right, triangle has vertices 6, -3, 2, -2, 1, and 2, 5. This triangle is going to be best classified as, okay, need a accurate grid here. Okay, you could draw it out. If you're just doing it on plain paper, it may throw off the diagram a bit. But how do you get accurate results, very precise results? Well, I'm going to be looking at the side lengths, so I have to work with all three pairs here. All right, and I have to apply the distance formula to all of them. All right, so I'm going to have distance 1 is 6 minus -2 squared plus -3 minus 1 squared. All right, that's for the first one. Then I'm going to have I'll do -2 minus 2 squared plus 1 minus 5 squared. Then I'll have 3, so it's going to be 6 minus 2 squared plus -3 minus 5 squared. All right, and as you're working these out, you're going to get two lengths that are the same, which means you have an isosceles triangle. All right, and that's all there is to this problem. All right, the coordinates of the vertices of a triangle are given below, which is a right triangle. Okay, this looks like quite a lengthy problem, but I'll show you what's happening here. Let me use these points here. So I'm going to use the distance formula. I'll do this. Let's figure out what the distance between the points are for KL. So I have 0 minus -3 squared plus 1 minus -8 squared, 3 squared plus 9 squared, 9 plus 81 equals square root of 90. We could just leave it like that. All right, then you have LM, which is the square root of -3 minus 3 squared plus -8 minus -5 squared. Then I have -6 squared plus -3 squared, which gives me 36 plus 9, which gives me 45. All right, then I have KM. So I have the square root of 0 minus 3 squared plus 1 minus negative 5 squared is equal to, I have negative 3 squared, which is 9, and then I have 1 minus negative 5, which is 6, and that's square root of 45. Alright, now since I have these lengths, alright, these are the sides of the triangle. I have 3 sides for my triangle. Alright. Now, if I use the formula a squared plus b squared equals c squared, it should work out. So if I plug that in here, square root of 45 squared plus square root of 45 squared is equal to 90. Square root of 90 squared. I get 90 is equal to 90. So the Pythagorean theorem works for these side lengths. So that's why answer choice D works. It's quite a bit of work to figure out, if all these points form a right triangle or not. But I don't think, or you won't have a problem this lengthy on the test. All right, but just be certain for how to figure out whether 3 points that you're given form a right triangle. If you have any questions about that, make sure to ask. All right, M is the midpoint of a line segment AB. Determine the coordinates of B. All right, so since M is the midpoint, you could easily tell where B is going to end up. So just apply the slope, down 1, right 2. And then you go down 1, right 2, and you'll end up at your other point. So here's the origin. So then my point would be at what? 3, 0. Done. All right, join AB on the coordinate plane, determine the midpoint of AB. Okay, let's see here. All right, there's my midpoint. If you're given a grid, it's pretty easy to tell where the midpoint is. So let's see the slope. Down 3, left 4. Down 3, left 4. Yep, that takes you to the midpoint. So your midpoint is going to be 0, 1. All right, otherwise, just figure out what the coordinates are for negative 2. And then over here we have 4, 4. All right, just use the midpoint formula, and you'll get 0, 1 that way as well. All right, find the area of the pentagon with vertices A, B, C, D, E. All right. Okay, here's the pentagon. The pentagon consists of a triangle and a rectangle. The area of the rectangle is what? 3 times 8, 24. And the area of the triangle is what? Let's see, what's the height? 7. So 8 times 7 times a half. So that's 28. 28 plus 24 is 52. Right. All right, draw the triangle by connecting the points A, B, C. How many square units are in the area of the triangle? Not very difficult to figure out. All right, so negative 3 to 4, that's 7 units. 4 to 2, that's 2 units. So it's just half times 2 times 7, which is 7. All right, that's all there is to it. If you have any questions about anything from the final review, please make sure to ask. And make sure you know all your properties and formulas. All right, that's all. We're done with the review.